So as you had mentioned at the beginning, it was only an 18 months project, which was aiming at using only available data sets. So both for atmospheric conditions, but also sea conditions, meaning that we didn't develop any new large models, but we took advantage of what was already there. And I think over these 18 months, we got a substantial piece of results that is very interesting to exploit. And if we go to the next slide, please, we can more or less summarize all the results concerning the wind, waves, and water levels, both for the main conditions for the future on the three sea fronts, and also for the extreme conditions. So the interesting thing to notice is that our results for the sea fronts in France are in most cases completely relevant with what is available in the scientific literature, mainly coming from the IPCC report from 2021 to 2023, but also results that were published sooner. So overall, we show that there's a decrease in the mean conditions for wind and waves, and an increase for water levels over all the three sea fronts, and there's an increase in waves and water level extremes. Uh, we have a slight difference with the literature, which is that for the extreme conditions about wind, we have less consensus than can be found in the literature, but that probably can be explained by the limited number of models we have, only 13 for the climate for the atmospheric variables. So that might be a limitation of our study. But overall, our results for France are really coherent with what was published in the literature. So with these results, we have the main trends, but there are uncertainties which are very significant, and we will try to show some interesting results in the next slides. So for that, we computed the what you may know as the stripes, the warming stripes, which were initiated by our colleague Ed Hawkins from the UK. So basically, it shows the anomaly of a variable compared to a reference, and in that case, it's the anomaly, the annual energy production anomaly for a specific NREL 15 megawatt turbine. And there we can see that from 1960 or so until the end of this century, under the SSP2 4.5 scenario, it's for the South Atlantic point, we have a decrease in the mean energy production. And so the message, if we look at this plot, is that overall there's an average wind energy production decrease in the coming years, or even in the coming decades. However, if we go to the next slide, what we represent here is only the median of the models we have, and in that case, it's 13 climate models. And so what we represent here is only the median. But if we add the uncertainties, which on the next slide are represented by the percentile 10 and 90 of the models, so the 10% and 90% values of the distribution from the 13 models, we can see that there is a significant uncertainty which comes from the models themselves. And so the message, if we still look at this plot, is that the evolution of wind energy production indeed has a tendency to decrease, but it is associated with an important model uncertainty. Now, if we go to the next one, and if we look at the SSP5 8.5 scenarios, so meaning high emission scenarios, we can see that the problem is higher, meaning that we still have some model uncertainty. So the spread between the 10% and 90% percentiles is more or less the same. However, the trend, the mean trend, is towards a larger decrease, which means that from our results, a high emission scenario would mean a larger decrease in the potential production from wind energy offshore in France. So the problem would be worse. And now if we go to the next slide, if we consider the SSP 1 2.6 scenario, which is more or less the one that is more or less compatible with the Paris Agreement, we can see that we still have this large uncertainty from the models. However, the trend is much smaller, meaning that limiting the emissions of greenhouse gases would be more favorable to the wind energy generation. From that, we can conclude that wind energy, which is a way to allow the energy transition and to reduce the carbon content of the energy generation, is favorable. And also that in case it is largely developed, which is a way to attain this decarbonization, it's also a way to limit the impact of climate change on the wind energy production. So it's a positive feedback that needs to be taken into account. However, like I said, there are still a large model uncertainties that needs to be taken into account, and we need to be cautious in the interpretation of the results. Next slide, please. So now we said that in 2C now we used existing data sets with a limited number of models. So that was the case for the atmosphere with only 13 models available, but it was even more the case for the oceanic component with 8 or 5 models available only for waves and for surges. And so now we clearly want to go further. For that, we are developing a new project, which is called 2C More. You can see on the left the structure of that project. So basically, we will work on the atmospheric climate datasets. For instance, by introducing some aspects that Butelina mentioned earlier with higher spatial and temporal resolution. We also want to work on ocean climate datasets because in that case, especially, we think that we have the right consortium to develop new ocean simulations based on climate projections to increase the number of data sets that are available to allow for better estimation of the results. We also want to work a lot on the mathematical methods for the climate science, talking about statistical downscaling, the estimation of extremes and the estimation of uncertainties. This part will also include potentially the application of new artificial intelligence techniques, so deep learning and so on, to better assess those aspects. And like in 2C Node, these developments, of course, are not done per se, but are the input data that will allow better application to the offshore wind industry aspects. Sorry. So both we will again work on the impact of climate change on wind power, of course, wind speed and wind power, potentially to have more accurate models, both in spatial and temporal resolution, but also larger number of models. We also want to go further in the estimation of the impact of climate change on the structures, especially turbines and the foundations and the floaters designs for floating cables, for instance, but also for floating power stations. And based on the very good work that was done on the offshore cable landing zones, we want to keep on developing those aspects to better determine what the impacts of climate change can be on the coastline due to erosion, because it has an important impact potentially on the way and on the structures that will connect the offshore wind farms to the onshore infrastructure, the network. And of course, the last part, but not the least, is the transfer to the industry. We will work from the existing platform that UN mentioned briefly, and that will be available publicly in a few weeks. To enrich it with new data sets, and also to develop tools and demo cases to show what the impacts of climate change might be on the industry. And of course, as Cedric mentioned, also we think it is important to develop all those aspects to better inform the people who define the standards related to offshore wind farms and offshore wind assets in general, because we are convinced that climate change needs to be taken into these standards to make sure that the asset will be will be resilient, sorry, to climate change in the future. So our network will be more or less the same as in the 2C Now project, but we also welcome new partners, for instance, BRGM, EMT Atlantic, and Central Marseille. But there are also others who we are discussing with. And just to let you know, the consortium is still open. In case you're interested, do not hesitate to contact us. So UN is the entry point, and we would warmly welcome additional partners. Keeping in mind that the goal of 2C More is also to extend the geographical extent of the project. So in 2C Now, we worked mainly on the France coastlines. But now we want to extend the study to other areas as well, so including Europe, but also potentially outside of Europe, in case there are some specific partners interested in other areas.